meaning me. I'm talking about me. All right. Moving on. Question. First of all, this was your homework. I should have told you that question 3, we did not cover. Question 6, we did not cover. And question 8, we did not cover. As for question 3 and 8, actually all 3 of them, they're more like questions that just don't pop up as regular plain old simple questions. They're those ones, you know how sometimes you have like a Regents question that has like a bunch of reading and then questions that go with it. Questions 3, 6, and 8 are questions that would be like that, where they give you a reading or a diagram and then ask you questions about the reading or the diagram. So it's not stuff you really need to know off the top of your head. All right, I have a question. How many of you for question 1 put epicenter? It's not the epicenter. What? So question 2, what did you put for question 2? Did you think they were both epicenter? Okay, so question 2 is epicenter. Reread those, see what the difference is between the 2 questions.
So is the first one plate boundary?
No. No.
The second one is,
The second one is epicenter. We already established that.
yeah,
So wait, here's what I just asked you to do though. Go back to the questions and see what the difference is between question 1 and question 2.
hey, how many actually told me?
Not cool.
Yeah, not cool, Sam.
Nope.
Alright,
What's the difference between question 1 and 2?
Spectrum.
Wait.
Huh?
Directly above.
Okay.
I don't know.
Okay,
Gross.
thank you. Alex, do you see the difference between the 2 questions?
You know, you the surface, looking for like the bullet.
So this one talks about the place on the surface. This one does talk about the originate, but it also says within the earth. So one is talking about inside the earth where the earthquake originates. And question 2 is talking directly above the place where the earthquake originates on the earth's surface. On the earth's surface is called the epicenter. Does anybody remember the vocab word for the one inside earth? No. So none of you looked back to page 16, which I did not take notes on page 16, but remember, so we have the definition of epicenter and the definition of focus. So the epicenter is the one on the surface and the focus is the one, yeah, it's the focus, is the one deep underground. So number 1, the answer is focus. Yep, so I was just going to say, I'm pretty certain I have never seen the Regents talk about the focus before. So just know that it's out there, it's an option, but epicenter is on the surface. It's the name of like the city where the earthquake happened. And then the focus is directly underground. That matters because if the earthquake is more shallow versus more deep, it would cause different amounts of damage depending on where exactly the plates were hitting each other. So like I said, number 3, we can get rid of. I will say that, just in case, I did mention this at one point, but you've heard of, like we talked about these with the different earthquakes we were doing, a 9.0 compared to an 8.0 earthquake. It's not just a little bit worse. It's 10, now I think it's 100 times worse. Might be 10 times worse. I don't remember off the top of my head. Not important for you guys either. So it's just not a little bit worse. It's a lot worse. Number 4, what type of waves will not travel through a liquid? S waves do not travel through liquids. That I am expecting you to know that. Number 7, so like I said, you could skip 5 or 6 there. 5 wasn't even a choice. 7, what type of earthquake waves travel the fastest? That is the good old P waves. Number 9, how far will an P wave travel P wave travel in 7 minutes and 20 seconds. So just travel 7 minutes and 20 seconds. Go over till you hit the P wave right there. So I got 4,200. Oh, good. And then the next question's almost identical, except for it's asking about the S wave with 5 minutes. Looks like I got 1,300 for that. You guys good with that, or you want me to double check it? Okay, as long as you're close. Now this one, again, the wording is a little bit different than we're used to seeing, but you know how to do it. An earthquake's epicenter occurred 6,000 kilometers away from an observer. What is the difference in arrival time between the P and the S wave? So this is our good old favorite here. It is 6,000 kilometers away. So I'm lined up on the 6,000. It's scrap paper because it was talking about arrival. So you mark off your zero, or you mark off the P wave, mark off the S wave, bring it down, and it looks like I'm getting about 740.
Yeah.
So again, you don't have to be right on with mine. I'd give you 20 seconds either way to consider you good.
See, I found both the thing and then I just like.
So that's definitely an option. I don't talk about it because I don't like when people do that extra of subtracting, but as long as you're good at subtracting, go for it. But a lot of people are not good at subtracting, and it's just a new place to make a mistake. All right, number 12, explain why you need a minimum of 3 seismic stations when determining the location of an epicenter. Were you able to put this in words? Kind of. Willing to share?
That, well, one's farthest away, yeah, like the farthest I can go, and then one's closest, and it's like at a line together.
Okay. It works. I don't know if it's the best answer, but totally get it. Totally giving you credit. Anybody else got one? An actual explanation? Yep, so that's not why we need the minimum of 3 though. So I'm not sure about your explanation either. Why can't we just use one circle?
Because then you won't know where in the.
Right. One circle tells us a lot of options. Why can't we just do 2 circles? Okay, when we have 2 circles, how many locations have we narrowed it down to? Let's look, drawing 2 circles. How many? Okay, maybe 2 circles on the screen. No matter how I draw 2 circles, how many times can I get them to meet? Wait, 2 circles, how many places do they meet? Yeah, one's here, one's here. This one is here and here, here and here. So 1 circle give us lots and lots of choices. 2 circles narrows it down to 3 or 2 spots. The 3rd circle, the only time it's going to, that'll only cross in 1 spot, no matter how it got drawn. So 3 circles narrow the options down to 1. I have never seen the Regents ask you to explain that in words either. So as long as you understand that you need 3 circles, then you'll be fine. What evidence do scientists have that indicates the Earth, it has a liquid outer core? Yes, that could have been a much simpler answer, is because S waves can't travel through. You said that, but you had a very complicated version of that. S waves can't go through it. So I have this, and I didn't show this to your class yesterday. I don't even remember if we did talk about it. So here's the Earth. Here's actually half of the Earth. If there was an earthquake over here, would they pick it up over here? What wouldn't they pick up? Just the S wave. So let me flip it over. So again, I was here to here. The earthquake will travel the fastest path through. So through the center. It doesn't go around the outside. It goes is the quickest path there. So if it's going from here to here, it's going this way. If it's going from here to here, it's going this way. So if we're trying to observe, oh, this is, yeah, Phoenix got down the globe for me. This is what I was trying to show you, but this was more helpful. So when it's going this way, the S waves get stuck in the outer core. Yeah. Want this back?
Like, earthquake happened in China.
China, us.
When we read the P waves,
Mhm.
how are we gonna figure out how far it is if we don't get the S waves?
We can't. We can't in the United States. We would have to rely on data from other places around the world. What we can say is, okay, there was an earthquake somewhere on the other side of the world from us, because we know there was an earthquake, we got the P wave, but we can't do all the earth science math stuff and figure out exactly where it was, because we don't have that data. We just know it's somewhere opposite us. But that's why these stations are all over the place. So they have lots of these, and I'm sure now they have even more now that there's computers and stuff. So I'm sure they're everywhere. And we can share data almost instantly, so. This chart you pretty much need to be able to fill out on your own. So by travel time, I just want to know which one's going faster, which one's going slower. P wave is faster. S wave is slower. I have, again, never seen them ask about travel direction, but what I need you to realize as I was talking about, this is the push and pull. And this one is the side to side. But if you did not know that off the top of your head, don't stress over that. And then what can P waves travel through? Solids and liquids. What about S waves? Phoenix, what can S waves travel through?
Solids.
Only solids. Now, finally, this last question here is one of those stupid ones where I think they're testing your reading ability just as much as they're testing your earth science knowledge. So let's make sure you read this one carefully. And then I want to show you one from lab that's been butchered all week. So it says, which statement best describes the relationship between travel rates and travel times of earthquake P and S waves from the focus of an earthquake to a seismic station? So the first half is asking P waves travel at a slower rate or S waves travel. What do we know? P waves are faster. So I can get rid of this one that says P wave. No, I can't. That was the wrong one to get rid of. I can get rid of the one that says, oh no, it was nice and organized until I screwed up. So I can get rid of the one that says P waves travel at a slower rate. Which other one can I get rid of? The third one. I can't get rid of the fourth S wave one yet, just the third one. It says S waves travel faster. Because it is true for number 4, S waves travel slower. But now we got to talk about the second half. Do P waves travel at a faster rate and take less time? Or do S waves travel at a slower rate and take less time? Which one takes less time? 2. P waves are going faster. So it means it's going to take them less time to get there. If you're in a Ferrari versus a school bus, you're going to be going faster in the Ferrari and it'll take you less time. All right, that's that. And I did want to show you one more from lab that has been screwing people up all week. And again, it's a reading question. So it's this number 1 here, and I'll read it in case you can't see it. It says, which statement correctly compares seismic P waves with seismic S waves? And our 4 choices are similar, but slightly different. So let's go ahead and read the first half. P waves travel faster or slower? Which ones, what do we know? P waves travel faster. So I can again get rid of the one that says slower and get rid of the one that says slower. So we're left with answer A or D. P waves travel faster than S waves and pass through the Earth's liquid zones, or P waves travel faster than S waves and do not pass through the Earth's liquid zones. It is not D. So D is saying P waves travel faster than S waves and do not pass through Earth's liquid outer zone. Did you read that as P waves travel then faster than S waves and then say S waves do not travel through the liquid zone? That's what everybody has read that has gotten it wrong. So at least you picked the good wrong answer, but this was a wording question. You had to read it the way it was written. When I read it the way it was written, it says P waves travel faster than S waves and do not pass through the liquid outer zones. When they're talking about the and do not, they're still talking about the P waves. If you read it kind of the way they expected you to read it, it would have said P waves travel faster than S waves and S waves do not pass through the Earth's outer core. So it was more of a reading question, but it is answer A. P waves travel faster than S waves and pass through the Earth's liquid outer zone. So you did, or outer liquid zone, sorry. So it was really a reading question, not an earth science question. I hate those, but the Regents loves them. So you do have to kind of slow down, read the words that are there, not the words you think are there. That's what really screws a lot of us up is we kind of like, oh, that's what they meant. That's not what they meant. They meant what they said. So read what they actually said. All right, so let's do Kahoot. If you haven't already booted up your computers or phones, go ahead and do that. I'll get the code going here in a second. You will need your reference table. I think we have really beat earthquakes into the ground at this point. So thanks for noticing. So I want to review the other half of the stuff that's going to be on the test tomorrow, and that's going to be pages 5 and 10 of our 5 and 10 of our reference table. Here is the code. What? Oh, sorry. Here is the code. Oh, classic mode start. Yeah, a little bit. Still can't see it, can you? There you go. There is the code. It's still under the words. Oh, turn up the music. Favorite part is the Kahoot music. Are 4 of you not logged in yet? Okay. Yeah, Kahoot. This is not the classic Kahoot noise. Is it? Is it just not the game yet? Is that why I'm not recognizing it? Are we all logged in? Okay, I was gonna say I counted 13. We're good now? No, I counted 13. Who's not in? I can start without you. You're gonna play, right? Okay, grab your reference tables if you don't already have them out. We're gonna be doing page 5, which is the plate boundaries, and page 10, which is the layers of the earth. So don't forget this stuff is on the test tomorrow too. Oh, good. We're switching over to some sort of yucky. Yeah, yucky snow something. All right. Yeah, we're not going home. I don't want to go home. As long as I'm here, let's do it. But man, I could use a snow day. My husband's only time his life was at risk when he was a trooper was when an empty tractor trailer going 65 miles an hour blew over and ran into him. Which type of boundary is between Africa and the Indian Australia plate? So you do have a minute to find this, so take your time. But look it up on your reference table. Well, I hope it was right, Phoenix. So you're looking for Africa and Indian Australia. Oh, did you screw up? To be honest, I gotta look it up, so. Africa. No, it's not. Yep, that would be a divergent. Let me just point that out. For those of you who thought it was a convergent. Oh, shoot, why are we not? Does it not get bigger? What the heck? Okay, well, it doesn't get bigger, but we're looking right here. Here's the African plate. Here's the Indian Australia. That is the two lines with it's this, which is divergent boundary. Oh, wrong button. It's over here. Next. All right. Yeah, Phoenix. Number 2, in which layer of the earth are convection currents found? This is on page 10. You can see it there, but it is also something I think you should just know. Convection currents are in the asthenosphere. So remember, the plates are the lithosphere. They float around on the asthenosphere, and that's where those currents happen that move them around.
Oh, yeah, look at that.
So you either got it wrong or you answered way slower than everybody else, which is not a bad thing on the regular test. Which tectonic plate is the Tasman hotspot found? Again, you have a minute, so take your time.
Can you move the camera?
Why do you care how many answered? Oh, if you're first.
How many times?
I don't remember. This is either the 14 or the 21 one. I don't remember which one I picked. Oh, I think there was an 18 one. Oh, goodness sakes, we got it. No, you didn't. What type of boundary is between the Nazca and the South American plate?
Purple.
Oh, you guys are getting a little into this.
Is that orange or yellow? Yellow.
I think it's orange, but I think it's supposed to be yellow.
Orange, yellow.
All right, so yeah, it's not complex. There's no complex anywhere over there. So if you said complex, were you just throwing numbers out there? Or letters or colors? It really, it's not. Let's just focus on ourselves. What can explain the marine fossils found in the mountains of New York State? Yeah, the Adirondack Mountains. Well, think it through. Which one could have moved marine fossils to the top of a mountain?
Circle.
So just by going, we're going to the top, we're going to mountains. Mountains are a lot higher up than anything else, especially marine stuff like water stuff. So the only way for fossils to get moved up is that they have been uplifted. In this picture, where would the oldest crust be found? Which letter has the oldest? Yes. Thanks to Phoenix and his family. We all remember that question now.
Nice meeting.
Appreciate it. Yep, this is 18. You were right, Alex. Which statement best supports the theory of continental drift? Don't make me play the song. I tried to get my youngest daughter to use Kahoot music for her floor music for gymnastics. She said no.
That's not ever.
I think it would be a good idea. Yeah, so the continents appear to fit together like a puzzle piece. That was, there was only 11, but there was enough time. No, we're on 8 now. Okay, guys, we didn't learn the moho. Let me show you where it is. The moho on page 10, turn to page 10. It's right here, right up at the top. See? Go over and see which 2 layers it's separating. Sorry, we did not learn the moho. Okay. So going back, so let's look at that reference table. I know mine's too far away for you to see, but you should be seeing here at the top of page 10 that the moho is separating the black outside layer, which is the crust, from the white teeny tiny layer, which is the rigid mantle. So the moho separates the crust from the mantle. Those of you who picked, what did you pick? That's an unfair generalization there, Sienna. I had Stanley's way before they were cool.
I'm getting one, I'm building one. I don't get me back now.
But now I've switched from Stanley to however you pronounce this water bottle, Owala. I like this one because it doesn't leak. See? P-wave recorded at 2:25 at a station 7,600 miles from the epicenter. What time did the earthquake occur? This is what we did yesterday. This is origin time. I clearly did not give you enough time, though. I'm sorry.
I got it.
I'm sorry to all of you. I did not give you enough time.
Oh, I got it.
Yeah, I definitely did not give you enough time. So
Darn it.
you had to go to 7,600. 7,600. It takes 11 minutes for the P wave to get there. So if it was recorded at 2:25, it took 11 minutes to get there. So you do 2:25 minus 11. Yep. Sorry, I definitely didn't give you enough time for that one. What is the pressure at the boundary of the lithosphere and the asthenosphere? What's the pressure? This is confusing.
But I got it right.
Oh, okay, that's it. So the lithosphere is that very thin white line there. The asthenosphere is the gray line. So you can see that this very first dotted line is marking off the boundary between the lithosphere and the asthenosphere. And I asked for the pressure. That's this graph. You can see at that dotted line, the pressure is basically not even off of 0. So, whoa.
Oh,
So the closest answer that would have been is 0.1. Those of you who picked 1,000, that's the temperature. And for those of you who picked 1.5, that would have happened. 1.5 would have happened right around here, which is boundary between the stiffer mantle and the outer core. So it's just taking your time and reading the graph correctly. No, I would like you to take it off because if you fall, you're going to get hurt. Yeah, the famous last words. Which layer of the earth is the temperature 5,500?
No. Oh, wait, never mind.
Oh boy, you guys fell for the oldest trick in the book. So 5,500 was a temperature. That's right here. Go over till you hit the black line. That puts you in the outer core. Those of you who said inner core, you did a temperature of 5,000 or a depth. I'm sorry. You did depth and you went up and that's inner core. So another case of please tomorrow, take your time, read the words, double check on the reference table. Oh, sorry, wrong button. Or lack of button. Scientists have inferred the structure of the earth by analyzing what? So we already talked about it. That's what we were looking. We know that the outer core is liquid because the S waves can't travel through it. So they analyze earthquake. Remember, seismic means earthquake. Hey, school, language.
see that potato?
But you used a bad word. You're so good at it, you don't even realize. Which feature is found along a divergent plate boundary? You did. You did. You used it as an adjective to describe something. Shoot, I meant to look at that. That was a ridge at a divergent plate boundary. Sorry, I got hung up on disciplining you. Compared to the Earth's continental crust, the Earth's ocean crust is... The picture might help. Oh, no. So the ocean crust, take a look at that picture. Maybe. Look how thin the ocean crust is. Look how thick the continental crust is. All right, I think we'll just stop there. Thank you very much for your part. Very nice, everyone. Test tomorrow. I would review the review sheet, some practice questions. We had a couple quizzes. That's a good idea. I understand. Apparently, I'm still playing.